Hi, today we discuss 4.3 transistor under chapter 4 electronics. So the first part, you must be able to describe transistor in terms of its terminal. Last time in 4.2 we discussed about diode. Diode is a PN junction. So what is transistor? So when you combine two PN junction, it will produce transistor. Okay, so transistor has three leads connected to the emitter, base, and collector. The emitter emits or sends charge carriers through the thin base layer to be collected by collector. So because of we are combining two PN junction, so there are two possibility of transistor that can be produced, that is Npn transistor and PNP transistor. So what is Npn transistor? So Npn transistor, the emitter sends negative electrons to the collector. Majority charge carrier is electron. In an PNP transistor, the P-type emitter sends positive holes to the collector because of majority charge carrier is hole. So in both cases, the arrow on the emitter shows direction of current flow. So you can see here, this is collector, three leads. C is collector, B is base, E is emitter. So across the BE, you can see there's an arrow. The arrow actually represents direction of current. And this one is P and P. For the NPN, we know that current always flow from positive to negative. So this one is NPN. So because of NPN, so current flow from positive to negative. So we mark direction is this way from B to E. It's same as the traditional current flow. This one is PNP. So PNP, collector is P, base is N, emitter is P. So direction of current always from positive to negative. Thus we mark here from E to B. So this symbol represent PNP transistor. Okay, in order to on a transistor, we need to make sure that base current flow. So in this case for transistor, the base current IB is used to control collector current through the transistor. The base current can be used to switch the collector current on or off. So it just like function as a switch. Okay, so this IB must flow first, then only IC will flow. Okay, let's discuss about the working principle, basic working principle of transistor. We look at here, this one is NPN transistor. So for the BE, B and E mean base emitter. So the base emitter is PN junction. So you can see direction is from B to E. Okay. So in this case, if you look at carefully, there are two circuits here. This part we call it base circuit, and this part we call it collector circuit. So collector circuit is connected to voltage of E1. The collector circuit connect to E2. R1 is for to limit the base current. Why? Base current is too small compared to the collector current. The unit of base current is microampere, while unit of the collector current is milliampere. So if you compare the magnitude of current, you can see IC is many times bigger than IB. So if we want to check the factor of magnification, so we can use this formula like current amplification, that is collector current divided by base current. Okay, it's maybe 100 times bigger, okay, or 500 times bigger. Okay, emitter current IE is equals to sum of base current and collector current. So you can see once the IB flow, then the collector current will flow. So in the end, when we total up the current IB plus IC is equals to IE. So in this case, IE is larger than IC, larger than IB. So if you look at here, When IB flow, meaning the the BE junction, the voltage can be overcome, junction voltage of BE overcome, meaning IB flow. So it's like open the door for the next charge to flow to C. You look at here, C connect to positive. So when this happens, it allows large amount of electron to flow to move to C, or to cross the junction to C, which is collector. When large amount of current go to C, meaning large amount of current will flow in collector circuit. So you can see from here, a small IB will produce larger IC. So that's the reason why transistor can be used as a current amplifier. So from the characteristic that we discussed before, a small change in the base current results in a big change in the collector current. So we can use current as amplifier. And we know that if there is no current flow in base circuit, then there is also no current flow in collector circuit. So IB 0, then IC 0, or we can say IC depends on IB. No IB means no IC. So you can see if IB 0 means transistor is switched off. If IB flows, transistor is switched on. And then we can say IC flows when IB flows. Okay, so that's the reason transistor can be used as automatic switch. So now we want to describe how transistor can be used as automatic switch. This one, automatic switch. Okay, so first we want to discuss about potential divider circuit. Okay, let's say we choose a suitable resistor R1 and R2. Variable resistor R1 and R2. So this is a circuit to explain transistor as a switch. So here we have a bulb here. So we need to make sure this bulb will light up. So you look at the circuit here. This is Npn transistor, collector, base, emitter. Okay. So we have one fixed resistor R1 and one variable resistor R2, meaning the resistance can be changed. Okay. Now we discuss how it works. If the variable resistance transistor is placed by a device such as light dependent resistor, maybe this one R2, you can use LDR, a thermistor, or a microphone, the transistor can be used as an automatic switch controlled by light, heat, or sound. How it works? Voltage at base terminal can be adjusted to switch the transistor on or off. So you can see this is part we call it base voltage. So you can see we only have one power supply here to supply the current. So R1 and R2 now we call it potential divider. Okay, so they are connected in a series. You look at carefully, R1 and R2. So if the variable resistor equals to 0, here R2 equals to 0, meaning voltage in the base circuit equals to 0. So use formula V equals to IR, the Ohm's law. So for R1 and R2, they are potential divider, meaning the voltage across the resistor depends on its resistance. You can see voltage directly proportional to resistance. So if R2 equals to 0, meaning voltage across base circuit also 0. So when the voltage in the base circuit is 0, it cannot overcome the junction voltage of BE. So transistor will be off. But if the variable resistor is increased, okay, so what happened to the base voltage? Base voltage increase. When the base voltage reaches certain minimum value, the base current switches the transistor on. Okay, so meaning if the base voltage here supply able to overcome the junction voltage of BE, thus IB will flow. So when IB flow in the base circuit, so what happened to the collector current? Collector current will flow in the collector circuit. So this result in the large collector current flows through the transistor, causing the bulb to light up. So let's say we use the same working principle to produce a light control switch by using transistor. So we replace R2 with LDR, light dependent resistor. So the special property for the LDR is LDR has a very high resistance in darkness and low resistance in light, meaning nighttime resistance will increase higher. Daytime, the resistance will drop. Another one, R, is a fixed resistor. So LDR and R must arrange so that it form a potential divider in the circuit. Okay, now look at how it works. Let's say the circuit switches on the light at daytime and switches off the bulb at night automatically. So how we arrange the R1 and R2? In order for the bulb to light up during daytime and switch off during nighttime, so we must put the variable resistor above here. Must put here. Okay, must put parallel to the bulb. And the other one, the fixed resistor, is in the base circuit. Okay. If you want it to function, circuit, which is the bulb lights up at night time and switches off during daytime automatically, so you just change position. Okay, the variable resistor you place in the base circuit, and another one is here, parallel to the bulb. Okay, so both will give different will cause the bulb to light up at different time. Okay, for example, the first one we will discuss about in daytime first. In daylight, LDR has a very low resistance as compared to R. Therefore, base voltage is high enough to switch the transistor on and to light up the bulb. Okay. In darkness, LDR has a very high resistance. Therefore, the base voltage is too low to switch the transistor on. The bulb lights up. Okay. You look at the diagram again, the circuit here. Let's say we discuss about daytime. You want to check how can the bulb lights up during daytime. So during daytime, the LDR, the properties of the resistance will drop. Okay. So when resistance drop, you can see the LDR and the fixed resistor here, they share voltage because they are potential divider. The total voltage is 6 volt. If resistance of LDR dropped during daytime, meaning the voltage across LDR becomes smaller. So when voltage taken by the LDR is smaller, meaning the voltage at the base voltage will be bigger. Let's say if LDR, the voltage is 1 volt, meaning the fixed resistor here is 5 volt. So the base voltage is larger. So the base voltage is enough to overcome the junction voltage or BE. Thus, transistor is on. As we can say, as we said before, when IB flow, IC will flow in the collector circuit. So now larger current flow in the collector circuit causes the bulb to lights up during daytime. Okay, this one is happen during daytime. Okay. And you also can discuss nighttime. In nighttime, resistance of LDR increases, meaning the voltage across LDRs become bigger. So voltage across fixed resistor is smaller, causes the base voltage become smaller. not able to overcome the junction voltage of VE, this transistor is off. So nighttime, the bulb does not light up. So it's only light up during daytime. So when you discuss the reverse way, so you can say we put LDR in the opposite direction. So we put LDR in the base circuit. So let's say we discuss about daytime. During daytime, resistance of LDR drop. LDR is in base circuit. So the voltage across LDR represent voltage of the of base circuit. So voltage of base circuit drop not enough to overcome the junction voltage of BE. The transistor is off. So during daytime, for this connection, the bulb does not light up. What happened during nighttime? During nighttime, resistance of the LDR increases. Thus, voltage of the base circuit increases and able to overcome the junction voltage. Thus, IB flow. When IB flow, transistor is on. Thus, collector current flow. The bulb lights up during nighttime. So this one, the bulb lights up during daytime. This one, the bulb lights up during nighttime. Okay, so that's all for this topic about the application of transistor as a switch and amplifier. Okay, see you next time. Bye.